Hello everyone, welcome to the video lecture series of Internet of Things. In today's lecture, we are going to discuss topic wireless sensor network. I am Professor Swati Suresh Pawar. Before starting with today's lecture content, let us revise the contents of the previous lecture. In previous lecture, we have discussed RFID basics, RFID principle, and RFID components. Now let us discuss wireless sensor network. Introduction to wireless sensor network. Wireless sensor network sends and gathers together data using sensor distributed spatially in the geographical region and collect it to a centralized location with the help of wired or wireless or sometimes hybrid network for processing. Usually WSN is used to detect the physical and environmental changes like temperature, pressure, motion, heat, etc. WSN focuses on sensing and gathering data and routing it for further processing. The motive behind vast development in WSN was military and battlefield surveillance. WSN has multiple nodes ranging from few hundreds to thousands in number scattered throughout vast geographical region. Each of these nodes at least has a sensor attached to it, obviously for the sensing purpose. Sometimes a single node has multiple sensors attached to it, that is temperature sensor, pressure, motion sensor, etc. A node has an electronic circuit interface for the sensor inside, a microcontroller, a radio transceiver with antenna and a battery as an energy source. This node senses the data and has a routing capability. This data is processed and provided to the end user in upper layers. Sensor nodes are usually connected to base station of sync that communicate between nodes and users. Intelligent logic can be provided here for processing or computing the data gathered by the nodes. The processed data is converted into user representable information and provided to the end user via internet connectivity. Routing protocol used in WSN are distributed and reactive, which means nodes look for a route to transfer data only when some data is gathered or intermediate nodes have some data to be transmitted. Ad hoc on-demand distance vector, that is AODV, and dynamic source routing, that is DSR, are used popularly for the routing. Figure shows the simple WSN architecture. Level 0 nodes that senses the data, level 1 nodes that process the data, and internet, that is level 2 nodes, delivers the informations. The topology of WSN can be a simple star topology or multiple hop mesh network. The lifespan of WSN depends upon the energy source of a node, as nodes are distributed over a large geographical area. So the algorithms and the protocol used in WSN must be fault tolerant and robust to increase the lifespan of the nodes. Mobile sensor network, that is MSN, is a WSN in which nodes are mobile and can change location based on their own or due to environmental changes. The main difference between the static WSN and MSN is the data routing mechanism. In static WSN, the route is mostly predictable as the nodes in the system hardly changes, but in MSN, the number of nodes in the network at given point of time may not be the same later on. Based on the number of nodes and their types of routing mechanism, and routes can change. The development in WSN has led to the inception of WSAN, that is wireless sensor and actuator network, which is capable of sensing environmental changes, processing this data and making decisions based on observations and performing appropriate actions. WSAN are used in battlefield surveillance, biological and chemical haphazards detection, climate control system, nuclear power plants, etc. Along with WSAN, one more Extended version of WSN is becoming famous, which is USN, that is Ubiquitous Sensor Network. USN is considered as a network of smart devices or sensor which will become universal global one day. Example of WSN: forest fire detection, weather monitoring systems, manufacturing process control system in large industries, hurricane avalanche detection systems, military surveillance, etc. History and context. History and context. Wireless sensor network in its evolution is equally contributed by scientists, researchers, and the intellectual commercial leaders of field. With the need of sensing, computation, and communication in top-level projects like smart dust in late 90s, WSN became a necessity. Size, power, and cost were the key area of focus at that time. WSN promises to address all these factors very efficiently. There were many conferences, interesting academic presentation, that is workshops, where the use and application area wireless sensor network are demonstrated very innovatively. The main motivation was to put low cost sensor anywhere and the efficient communication can be achieved without wires. Soon the diverse fields shown the interest and started incorporating WSN in their applications area like light control, access control, home automation, heating, ventilation, air conditioning, that is HVAC, smart transportation, etc. With increasing use and demand of WSN, IEEE came up with the first version of IEEE 802.15.4 in 2003. This addresses both MAC and physical layer. The nodes. The node or WSN wireless mode is tiny intelligent unit containing few integrated ICs. These may be powered by battery. More sophisticated modes can opt for alternate source of power like daylight. Central to the mode is the most intelligent chip called the microcontroller, where all the tiny peripherals and other secondary chips got connected. This acts as the tiny processor within the mode. This intelligent piece of processor or the microcontroller controls the sampling of communication and radio chip. Microcontroller sends the signal to radio chip, which in turn sends it to the antenna of mode. Dedicated sensor chips in the mode are responsible for sensing the digital or analog data based on the type of application, capability of sensing chip. Now the connecting nodes. Radio frequency is the most basic, widely used methodology for connecting nodes. Transmitter does not send constant wave signal. Instead of transfer information, some aspect of wave is intentionally changed. This is called the modulation. On-off keying is simple mechanism where the tone is turned on and off to convey the information. In some form of communication, the tone is not entirely turned off. Instead, amplitude is changed. This is called ASK, that is amplitude shift keying. In other case, the transmitter modulates the frequency and this is called as a PSK. Sorry, it's called as FSK, that is a frequency shift keying. Another is PSK, that is phase shift keying, where the signal is transferred by the modulating the phase of the carrier. Interference or the unwanted components received by the antenna. Sensitivity of radio can be defined as the amount of power required to achieve the specific bit error rate. This depends upon the amount of noise present and on the signal to noise ratio. Ensuring the reliability in successful connection and communication of wireless nodes is one of the key challenging area of wireless sensor network. Networking nodes. Encapsulation of many components inside the mode is required to make it successfully communicate over the network. Making the mode available on a network and making it available over multiple hops has many inherent challenges. The firmware or software inside the mode has to decide on the protocol, timing, frequency, etc. of communication. Complex but small codes are needed to run inside the mode. These are mostly existing in the form of firmware. Once written, it runs for lifetime. More sophisticated modes, however, have provision of firmware updates. Layers of communication plays an important role, making the available and serviceable over the network. The most important layer for the mode is the media access control layer. It controls the state of WSN chip. It includes duty cycle and energy aspect of nodes. It also has to address changing topology of wireless sensor network. More sophisticated WSN MAC has the provision switching of the modes in inactive hours. MAC is designed for power supply coordination. Power is supplied only when the communication needs to happen. These are energy efficient MAC protocols. Preamble sampling protocols also contributes in successfully operating and networking nodes. It has the feature of listening for very short time to sense the ongoing transmission. CI, that is check interval, is the term used to define duration of time the mode waits between two transmissions. A part of it, frame MAC protocol, is also there, which formulates a schedule that all other nodes follow for the transmission. This saves the energy but requires greater intelligence for the coordination. WSN and IoT. WSN has many features that makes perfect companion of IoT, like nature of being distributed, ubiquitous, dynamic, etc. Below are the few features of WSN that makes it popular and desirable for IoT application. WSN consists of network of distributed sensor or collection of sensors that act as nodes that collects actual data in the environment. It helps in many sensor-oriented IoT applications. WSN also has routers and the coordinators. Routers help transfer the collected data from the nodes to coordinators for further processing. Once this data is collected, this data can further be transmitted to the internet where the coordinators act as a gateway. This feature helps the things to get organized around the internet. WSN provides self-organizing and self-configurable network. And along with this, the ability to provide environmental and physical condition monitoring using large number of low-powered and low-cost nodes makes the WSN very useful. As WSN has large number of nodes, manual setup is very tedious task. Self-organizing capacity of WSN makes adding new nodes or removing old ones easier. This makes the WSN smarter and a perfect companion for smart IoT applications. Some example of WSN used in IoT systems are: WSN is used to monitor soil moisture level in different regions of land in agriculture IoT systems. Indoor WSN checks air quality and level of various gases in the room's environment in indoor case study of home management IoT based system. WSN helps to collect the data like temperature, humidity, pressure, etc. in the atmosphere to correctly deduce weather condition in weather monitoring system. Building maintenance system deploys WSN to check pressure, vibrations in building, bridges, etc. Motion detectors deployed in WSN is frequently used in surveillance system. Summary of today's lecture. In today's lecture, we discussed introduction to wireless sensor network, history and context, the nodes, connecting nodes, networking nodes, WSN and IoT. Thank you.